Welcome back. In this class, we're going to talk about substitution reactions. Remember, there are 4 types of reactions that you have to be able to identify on the exam paper. And substitutions are the first reactions that we're going to see. There are 2 types of substitution reactions that we study in this section. The first type is the halogenation of alkanes. That's where one of the hydrogen atoms on an alkane is substituted for a halogen, which would be chlorine, bromine, fluorine, or iodine. The second type of substitution reaction is esterification. This will be covered in a separate video just to try and keep the video a little bit shorter. I know I've struggled with that. So, in this section, the substitution reactions are very common in question 8 in the organic synthesis question, but also in question 10 for 25 marks. It's very commonly asked to write the mechanism for the reaction, but also there's a couple of extra bits of information that the examiner is looking for, like pieces of evidence or the second or the longer chain hydrocarbon that's formed and where does it come from. Okay, so let's look at what we need to know for the substitution reaction question. This list looks a little bit longer than some of the other classes that we've done, because there is quite a lot that the examiner expects from you here. But if you can write the mechanism and do a really good job on the mechanism, the rest of it actually falls in line behind that. So that's where our focus is going to be in this class. So number 1, what do you need to be able to do? Number 1, you need to be able to identify a substitution reaction if the examiner has provided you with a balanced equation. So they will give you an exam question and there will be a balanced equation in the question, and they can ask you what type of a reaction is this? And what they're expecting from that answer is it addition, substitution, elimination, or redox? Number 2, the examiner can ask you to describe the 2 types of substitution reactions. Now with this, it would just be that you can identify them from the balanced equation, but it's a little bit longer. So number 1 is the halogenation of an alkane, and number 2 is an esterification reaction, where an alcohol reacts with a carboxylic acid to form an ester plus water. Number 3, you should be able to define a free radical, a chain reaction, and a substitution reaction. The most important of the 3 of those is the free radical definition. Next, you should be able to describe the mechanism for the halogenation of an alkane. This is a common 12 to 15 mark question, so it is quite a big one. Number 5, you should be able to name the longer chain hydrocarbon produced. Number 6, name a substance that you can use to speed up the rate of the reaction, and that will be dependent on what the alkane is. Number 7, you need to be able to give 3 pieces of evidence for the free radical substitution mechanism. Right, so let's start with substitution reactions. So the definition for a substitution reaction is a chemical reaction where an atom or group of atoms in a molecule is replaced by another atom or group of atoms. Now, an example of this type of reaction. So if I go down to the bottom of the page, we start off with an alkane, like methane. Now, alkanes in chemistry are rubbish. They are super unreactive. They do undergo combustion, but they don't do a whole lot else because they are non-polar covalent molecules. They don't have the permanent delta plus or delta minus partial charges on the molecule, which means it's very difficult for them to rearrange their electrons. Now in this one, we have methane, and if that was to come into contact with something like chlorine. Now, I'm actually going to colour code the chlorines. I'm going to put one of them blue and leave the other as white. Now, what happens here in this substitution reaction is one of the hydrogen atoms on the methane, it doesn't matter which one we pick, they are all the same. So I'm going to pick this one here. That hydrogen atom is going to swap with one of the chlorine atoms. So they're going to swap places. And what we end up with is a methane molecule, but now we have a chlorine on the methane molecule, and the hydrogen swaps with the chlorine to form hydrogen chloride. Now here, it's important that you name that second product as hydrogen chloride. A lot of students fell into this trap in 2024 where they called it hydrochloric acid. It's not. There's no water anywhere here, so it can't be hydrochloric acid. Now, why is this classified as a substitution reaction? If you look on the left-hand side of the screen, you have two reactants on the left, your methane and your chlorine, and you have formed two products on the right-hand side. When you start with two things and end up with two things, we're going to classify that as a substitution reaction. But when you dig into it, basically all we have done is substituted one of the hydrogens for a chlorine atom. You've just swapped them around. Now, in this section, we're going to talk about the halogenation of alkanes as the first reaction that we need to discuss. Now, the halogenation of alkanes is basically where we are going to put a halogen on an alkane, like we saw in the previous reaction. Now, the halogens, let's talk about those for a second. The halogens in chemistry are the group 17 elements. And they include chlorine, fluorine, bromine, and iodine. Now, when we're undergoing these types of reactions, you're not going to be saying it's a chlorine atom that's reacting with one of the alkanes. Instead, we can use this to figure out what the second reactant is. If you're putting chlorine onto an alkane, the reactant that you will use is chlorine gas, which has the formula Cl2. It's a molecule of chlorine. Chlorine atoms cannot exist on their own. They're too reactive. They want a stable outer octet. But they're in group 7 or group 17, so they have 7 electrons in their outer energy level. They form bonds with another chlorine atom to form a chlorine molecule. If you were dealing with F2 or fluorine, or you're putting fluorine onto an alkane, your second reagent would be F2. If it was BR that you're putting onto the alkane, well then your second reagent would be BR2. If you're putting iodine, it's unlikely that you will be asked that, it would be I2. Now, for the alkanes themselves, alkanes are a bit rubbish in chemistry. They are super unreactive. They're not like the alkenes, which we will see in addition reactions later on. Alkanes are really rubbish. They undergo substitution reactions, but they don't undergo addition reactions. They can't. They don't have enough electrons in their carbon-carbon bond for them to undergo addition reactions. So if we look at ethane on the screen. Now, if I want to take ethane and form chloroethane, so I'm going from an alkane to a chloroalkane. The second product or second reactant that we need to react with this would be chlorine or Cl2. Now, with chlorine, that is chlorine bonded to chlorine. If this was undergoing a substitution reaction, one of the hydrogen atoms on ethane is substituted for one of the chlorine atoms. And we will form this molecule on the right, which is chloroethane. And my second product, remember the hydrogen from the alkane is swapped with that chlorine, so you have hydrogen chloride. Now, with substitution reactions, make sure you show the second product, which would be your hydrogen chloride. Quite often in the exam, you are actually asked for the identity of this compound. They call it the inorganic compound, and that's what they're looking for. That actually was asked in 2023. They were asked to identify the inorganic compound, and the examiner was looking for hydrogen chloride. Right. So that's if we're reacting ethane. Now, if I was to put something else on that alkane, so say for example, instead of forming chloroethane, I wanted to form fluoroethane, where I'm putting fluorine on the alkane. Well, then you would need to use F2, which is fluorine attached to fluorine. One of the hydrogens is replaced by the fluorine and vice versa. So your product would be fluoroethane and then hydrogen fluoride. Same as before, but now you've got fluorine instead of chlorine. Now, that's putting a halogen onto an alkane. Now, with these types of reactions, there's a very specific type of reaction needed to make this happen. If you were to take ethane and mix it with fluorine and just let it sit there in a container, absolutely nothing is going to happen. It can't. Because you have ethane, which is non-polar, and fluorine, well, it's relatively stable because it has a stable outer octet. So not very much is going to happen. So we need something that's going to break the bond between the two fluorine atoms. Now, this type of bond breaking. So we're going to shine light on the sample in the container. Now, when that happens, the fluorine-fluorine bond is going to break. Now, if we go back and have a look at the dot and cross diagram for fluorine, I have one fluorine atom. It's in group 7, so it has 7 electrons in its outer energy level. And it's bonded to a second atom of fluorine, which also has 7 electrons in its outer energy level. So there is a covalent bond between my 2 fluorine atoms. Technically, it is a sigma bond. Now, those 2 electrons are shared between your 2 fluorine atoms, and they are equally shared. Now, if I was to break that bond, and you can do that by shining a certain frequency of light on the sample. Light provides the energy needed to break the bond. If we were to shine UV light on the fluorine, that causes the bond between the 2 fluorine atoms to break, and it breaks in a very specific way. If I represent this slightly differently, and that bond holding your 2 fluorines together, one electron in that bond came from the fluorine on the left, the other electron in that bond came from the fluorine on the right. When UV light shines on this molecule, it causes the bond to break. And it breaks in a very specific way. One electron goes to the atom on the left, and the other electron goes to the atom on the right. So if I was showing this electron here goes to the atom on the left, and the other electron goes to the atom on the right-hand side. Now, that type of bond breaking, where when your bond breaks, one electron goes to each atom in the bond, this is called homolytic fission. And this is needed to break the bond between the 2 fluorine atoms. But when that bond breaks, you form something called a free radical. Now, what the free radical will look like is this. That electron stays with the fluorine on the left, and it still has its other 7 electrons. And the other fluorine has its own 7 electrons like that. A free radical in chemistry is where you have an atom or group of atoms with an unpaired electron. And that's how the free radical forms here. The free radical, because of the unpaired electron, both of those have unpaired electrons, they are super reactive. They are very reactive because your free radicals, for want of a better way of saying it, want a stable outer octet. So they're going to react very quickly to get that stable outer octet. This is the only way that an alkane will be able to react with a halogen, because you've formed a halogen free radical, and that basically is, in a roundabout way, going to rip one of the hydrogens off of the alkane, and then you substitute the other alkane on first. Now, for this type of a reaction, how do I know this is what happens here? Now, we will talk about the evidence later on, but why does this not happen with alkenes? Alkenes are different. Alkenes have a carbon-carbon double bond, and they have the general formula CnH2n. That double bond between the two carbon atoms is high in electron density. There's a lot of electrons there. There's 4 electrons, whereas in a carbon-carbon single bond, there's only 2 electrons between the carbon atoms. That high electron density allows ethane to undergo a different type of reaction, and we'll see that when we get to addition reactions later on. But alkanes do not have that same high electron density, so they can't undergo addition reactions. They have to undergo what we call free radical substitution. Now, that term, free radical substitution, this is how we will halogenate an alkane, where we put a halogen onto an alkane. Free radical substitution means you are going to form a free radical and then cause the substitution reaction to happen. Right. If I wanted, before I move on, say for example, if I clear the reaction I had up there that we talked about earlier, and we give a different one. So if I have ethane and I want to put chlorine or substitute chlorine onto this, well, your second reagent would be Cl2. And my product, once you shine UV light on it, is going to be chloroethane. And the second product would be hydrogen chloride. Now, if I wanted to put more than one chlorine onto that alkane, well, then you would need lots and lots and lots of chlorine molecules inside the container with the alkane. If you have lots and lots and lots of chlorine molecules, your chlorine is in excess. And then once you have formed chloroethane, well, then there's nothing stopping it reacting with another chlorine free radical. And that's how you would get more than one chlorine atom onto the alkane. You would need to make sure that your chlorine reagent is in excess to allow another substitution to happen. If you left it long enough, it would replace all, or could potentially replace all of the hydrogen atoms. Right, so next, the definition for a free radical. Now, we've already discussed what a free radical is, but it's really important in the exam that you can tell the examiner what it is. So let me move this down. A free radical is an atom or group of atoms that has an unpaired electron. Now that phrase, unpaired electron, that's what we're going to be looking for on the exam paper. Now the unpaired electron is represented with a dot. So if I was showing you that chlorine, Cl2, when you shine UV light on it, splits up into 2 chlorine free radicals. The chlorine free radical is represented with a dot. Now be careful here, it's not an ion. When you break the bond between your 2 chlorine atoms for this reaction, like this, the electrons in that bond, 1 electron came from each chlorine. So when you split that molecule up, the chlorine on the left got its own electron back, and the chlorine on the right also has its own electron back. So you haven't gained or lost electrons here, so we don't have ions. So be very careful when you're dealing with substitution reactions that you show the free radical as a dot, not as a minus. If that was a minus sign, that means you're telling me that the chlorine has gained an electron, but that hasn't happened here. That would be if something has lost an electron and now I have that extra electron went on to the chlorine. So the chlorine has 1 more electron than it does protons. And in that case, if 1 chlorine had lost, if that had happened, let me show you what it would look like. Well, the chlorine on the left would have gained an electron and be negatively charged. The chlorine on the right has lost an electron, so it would be positively charged. But that's not what's happened here. So we can't use charges because it doesn't make sense. but both of those atoms have unpaired electrons, so these ones here. And because both of those atoms of chlorine, they want to be more stable, they want a stable outer octet, they're going to react super quickly to get that extra electron to satisfy the octet rule. Now, this type of bond breaking, where one electron goes to each atom, so one electron in the bond goes to the atom on the left, the other electron in the bond goes to the atom on the right, is called homolytic fission. Now, when I did the introduction to the organic synthesis, we talked about the two different types of arrows. So if I draw a chlorine bond. Now, that bond between the two atoms is just 2 electrons. That's all that is. That's all a bond actually is. You've overlapped your atomic orbitals, and inside that overlapped space, you have 1 electron from each atom. Now, when this bond breaks, 1 electron goes to the atom on the left, and that's why that arrow is shown as a half-headed arrow. The arrow starts from the bond because that's where your electron was. That's where the electron was at the beginning of this type of mechanism. And it points towards the chlorine because that's where the electron went to. It went from the bond to the atom. Then on the other side, the other electron goes to the other chlorine atom. And again, it's a half-headed arrow because remember the two types of arrows. We have this type, a half-headed arrow, and this one, which is a double-headed arrow. The half-headed arrow is the movement of 1 electron. The double-headed arrow is the movement of 2 electrons. And when you are dealing with homolytic fission, you have to use the half-headed arrow. With the double-headed arrow, we will call this heterolytic fission, which you will see later on. But when you're dealing with halogenation of an alkane or free radical substitution, it's the half-headed arrow that you're dealing with. So this one here. With the double-headed arrow, so the one on the bottom, this one you will see in addition reactions, and you're not going to use it before then, okay? So we've homolytic fission here, 1 electron goes each side, and we form 2 chlorine free radicals. Now, if this was you were forming fluoroethane or bromoethane, well then you would be starting with F2 or B or 2. But chlorine is the one that most people seem to remember, so that's the one that we're going to show in ours. Now, the next definition is for a chain reaction. Now, the chain reaction is a reaction that continues on and on because the product from one step is a reactant in another step of the reaction. A chain reaction is very important here because by just using 1 photon of UV light, we're going to end up forming tens of thousands of product molecules, even though we have only broken 1 halogen bond and split it up into the halogen free radicals. Okay. Now, I will show you the chain reaction step during the mechanism, and it's really important that you can identify this because the examiner quite often asks you, well, which step in the reaction is the chain reaction step? So you need to be able to name it and identify it as the chain reaction step. Okay, now for the chain reaction step, just watch out for that in our mechanism. Now, I'm just going to move my face out of the way for a second. So, from my mechanism, free radical substitution, where we want to describe the mechanism for the formation of chloromethane. Now, before we begin, we're going to set ourselves up for success here, because I wasn't generous enough to tell you what the 2 reactants in this particular reaction are. I didn't say what reacts with what. So we're going to see if we can figure it out just based on the information that's given. Now, why that's important is when you're in the exam, the examiner might not tell you that this is a substitution reaction. So you need to be able to figure that out for yourself based on the information that's given in the question. So we want to form chloromethane. Now your hint here is the word methane. Methane has the formula CH4. It is an alkane. Now alkanes undergo free radical substitution. So it's a substitution mechanism that we need to show. And when you look at what I'm putting onto the alkane, It's chloromethane. So my other reactant is going to be Cl2. And so therefore we have the halogen molecule reacting with my alkane. Now I'm going to get rid of these two just to give myself as much space as I possibly can when I do this mechanism. Right, step 1 in the mechanism is to form your free radicals, and this step is called initiation. During initiation, I know one of my reactants is chlorine, so you take your halogen molecule, you shine UV light on it, and that causes the bond between the two chlorine atoms to break. One electron in that bond goes to the chlorine on the left, the other electron in that bond goes to the chlorine on the right, and you form 2 chlorine free radicals. Now, I recommend putting in what type of bond breaking that is. It breaks by homolytic fission. Perfect. Now, that's your first 3 marks in this mechanism. So we've got 3 marks out of my 15 for all of that information there. Step 2. We need to make the free radicals react. So we're going to take a free radical from the previous step and react it with a molecule. This step is called propagation. Now, a key feature of a propagation reaction is where you take a free radical and it reacts with a molecule. But you also regenerate a free radical on the other side. So when you're writing this step in the mechanism, there should be a free radical on the left and on the right. Propagation reactions have a free radical on each side. It's not the same free radical, but there is one on each side. So we take our chlorine free radical from step 1, and now we react it with the alkane, the second reactant, which we said was methane. The chlorine free radical is super reactive, so it basically rips one of the hydrogens off of methane. Now, to show how this happens, so it's going to take one of the hydrogens off. I'm going to pick that one, but it doesn't matter which one you pick. So my unpaired electron from the chlorine free radical comes in. Now I'm showing it in the space between the hydrogen and the chlorine because this is where the bond is going to form between those 2 atoms. So that's where the electron moves to. Now we look at the carbon-hydrogen bond in the methane. Now that bond has 1 electron from the hydrogen and 1 electron from that carbon. We're going to break this bond between the carbon and hydrogen moves its electron to form a bond between the hydrogen and the chlorine. That forms hydrogen chloride. But now that second electron from the bond between the hydrogen and the carbon stays with the carbon. Now the carbon atom has an unpaired electron. So you have formed a methyl free radical. Now showing all of that, that's going to get you 3 marks in the exam. My next step, step 3, this is perhaps the most important step. Step 3 is also called propagation. We start with a free radical, we end up with a free radical. So we take the free radical from the previous step, which was my methyl free radical. Now it has to react with a molecule. During this step, the propagation step, the second propagation step, this step will form the product that you're asked for in the question. So if we look at the question at the very beginning, we're asked to form chloromethane. Now, I have a methyl free radical. It doesn't have a chlorine on it yet. So that actually tells me what this is going to react with. That's the free radical, your methyl free radical. That has to react with a molecule. So it has to react with Cl2. Now, when this happens, your carbon unpaired electron comes in to form a bond. You break the bond between your 2 chlorine atoms. 1 chlorine moves in to form a bond between it and the carbon. And the other electron in that bond stays with the chlorine on the right-hand side. Now this will form chloromethane, which is the product that we're asked for, but it also forms a chlorine free radical. Now for what I've shown so far, I've got 3 marks. I'm at 9 marks out of 15, so I've picked up loads of marks for this. But why this is so important is this. You have formed a chlorine free radical, which can now go back around to this step here. You have regenerated the chlorine free radical. So basically, after you form one chloromethane molecule, your chlorine free radical can now go and attack another methane molecule. So by just breaking one chlorine-chlorine bond at the beginning, you can generate tens of thousands of chloromethane molecules, because your reaction is going to cycle through step 2 and step 3 tens of thousands of times. And that's why that reaction step is called the chain reaction step. Now it's important that you can label this as the chain reaction step. And for calling this the chain reaction step, we get another 3 marks. So right now I'm at 12 out of 15. My last step in this mechanism is step 4. Now this step is to show how do we get rid of the free radicals? How do you stop the free radicals from going round and round again and again and again in the propagation reaction? During termination, this is where 2 free radicals combine. Now there's 3 different steps that you can give here, or 3 different reactions that can happen here. However, I would be inclined to give the one that forms the product that you're asked for in the question. So we're going to give the combination of 2 free radicals that will form chloromethane. So we take our methyl free radical with our carbon with our unpaired electron, and we combine it with a chlorine free radical. The unpaired electron from the carbon comes in to form a bond, and so does the chlorine unpaired electron. And by doing that, we form chloromethane. Now that's technically all you need to show me, and I'll give you 3 marks. So that gets me to 15 out of 15. However, there are another 2 termination reactions. If a chlorine free radical combines with a chlorine free radical, so we move our electrons in to form a bond between my 2 chlorine free radicals, that will form Cl2. Again, if you gave that one instead of the first reaction, you will still get 3 marks for that. I think it's kind of cheating a little bit, but you'll still get it. Now the last one, this one's really important. If you take your methyl free radical and it was to combine with another methyl free radical, your unpaired electrons come in and form a bond between the 2 carbon atoms. So my longer chain hydrocarbon has 2 carbons and 6 hydrogens. In this case, my longer chain hydrocarbon is going to be ethane. Now, in the exam, the examiner is 100% going to ask you about the longer chain hydrocarbon. They might ask you to name the longer chain hydrocarbon. Now, how you figure that out is you go back up to step 2. And you look at the hydrocarbon free radical that's formed in step 2, which is here. Now here, we have a methyl free radical. If you want to figure out what the longer chain hydrocarbon is, you take that and you double it. So that would be CH3 times by 2, which will be C2H6. Now, when you double it and form C2H6, you know that that is an alkane because it has the general formula CnH2n plus 2. And it's 2, so it has to be ethane. Now I'll show you a different mechanism in a minute that's not going to form a methyl free radical. It forms a different type of free radical, and we will still be able to work out what the longer chain hydrocarbon is from that one. Now if I go back down here again to my longer chain hydrocarbon, this is the least likely termination step to form the ethane. Ethane will be present in trace amounts in the reaction container. There's not going to be a whole lot of it there. And the reason for that is, in order for you to form ethane, two methyl free radicals, 1, 2, have to combine or collide with each other. The likelihood of two methyl free radicals being side by side and available to collide with each other only is incredibly unlikely. Your methyl free radical is much more likely to collide with chlorine because chlorine is in a much bigger concentration inside the container. It's one of the other reagents, so they would have pumped lots of chlorine into the container to ensure that it reacts with the ethane, or methane in this case. So your methyl free radical is in a small concentration because you're forming it during the reaction, but your chlorine would be in a much higher concentration. So it's much more likely that your methyl free radical will combine with chlorine than it will happen to be beside another methyl free radical at the right instant where they can combine to form ethane. So ethane is there, but it's there in a very, 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 very small amount. Now that is my 15-mark mechanism. Now to help you, we're going to do another one. Now for this one, I want you to try and have a go at this by yourself. So pause the video and see if you can figure out the mechanism on your own first. Now I will say this, I should have said it at the start. The mechanisms are tricky. I always tell my own 6th years that when it comes to them doing this one in particular, they're going to have to write this about 10 times before they're in any way familiar with it. And even when they write it out 10 times, they're probably only going to get 80% of the marks. It takes a lot of practice, but when you crack it, you can write the free radical substitution for any alkane and any halogen because the steps are going to be the same. So we're going to describe the mechanism for the formation of fluoroethane. Now here, we have to figure out what our reactants are. Well, we know that we're forming fluoroethane, so that hydrocarbon is telling me what the hydrocarbon is. We need to have ethane, which is C2H6 as one of the reactants, but we're going to put fluorine onto ethane, which means my other reactant or my halogen has to be F2. So for my initiation step, we're going to start with F2 and split it into two fluorine free radicals. Right, so step 1. We have initiation, where we have a fluorine molecule. You shine UV light on it and it splits up into two fluorine free radicals. One electron in the bond goes to the fluorine on the left, the other electron in the bond goes to the fluorine on the right. And this happens by homolytic fission. There's my first 3 marks. Step 2. Now we need to take that free radical and make it react with a molecule, and we call this propagation. Now the fluorine free radical from step 1 is going to react with the hydrocarbon that we identified is the second reagent, which was ethane. Now here, it doesn't matter which hydrogen you pick. You can pick any of the hydrogens, they're all the same. So I'm just going to pick the one that's beside the fluorine. The unpaired electron from the fluorine comes in and we form a bond between it and one of the hydrogen atoms. The other electron in that bond stays with the carbon. This will form hydrogen fluoride, and now we have generated an ethyl free radical. For this step, we get 3 marks. Step 3, now luckily step 2 and step 3 have the same name. So step 3 is also called propagation. Now remember, with propagation, we start with a free radical, we end up with a free radical. So we take the ethyl free radical from step 2, I'm just turning it around, and now it has to react with a molecule to form the product that was asked for in the question. Now we want to form fluoroethane. There's my ethyl free radical, there's no fluorine on it yet. So it has to react with a fluorine molecule. Your unpaired electron comes in to form a bond between the carbon and the fluorine. The bond between the two fluorine atoms breaks. One fluorine moves to form a bond with the ethyl free radical, like this, forming fluoroethane, and the other fluorine exists as a fluorine free radical. Don't forget to show the dot for the free radical. For this step, we now have 3 marks, so we're at 9 out of 15. Don't forget to call this, it's a very specific name. This is the chain reaction step. And we call that the chain reaction step, and now we get another 3 marks. Your last step is to show how do we get rid of the free radicals and stop them from undergoing propagation. So, apologies. So this is called termination. Now, I like to show the termination reaction for the 2 free radicals that will give you the product that we're asked for in the question, but it's not essential. So that means I'm going to take my ethyl free radical and combine it with a fluorine free radical. And we form a bond between the carbon and the fluorine, and we have fluoroethane. There we go. And that'll be my next 3 marks. And that brings me to 12. Now you can give one of the other termination steps. So my other one, if I move that up, if you have 2 fluorine free radicals combine, form a bond between the 2 fluorine free radicals, that will form F2, or we have the longer chain hydrocarbon. Now here, remember we go up to step 2, which was up here, the first propagation step, and you identify what your hydrocarbon free radical is here. It is an ethyl free radical, which has the formula C2H5. Now, I want to figure out what the longer chain hydrocarbon is, so you take that and you multiply it by 2. That will give me C4H10, which is butane. So I need to draw butane down here. So we combine 2 ethyl free radicals, form a bond between the 2 free radical carbons, and again, that longer chain hydrocarbon here would only be present in a very small amount because it's more likely that your free radical will combine with fluorine. There we go. Now, and that is my free radical substitution mechanism. It is a very common question in the exam. Now, to be honest, you're going to look at that and go, oh my God, that's really hard. Yeah, it is. It absolutely is. Every student struggles with this. Every single one of them. I have yet to come across a student that looked at this and went, they get it the first time that they see it. You're just going to have to sit down with pen and paper and work your way through it and track the movement of electrons. And I will say this, if you plan on doing chemistry in college, when you get to 3rd year, one of the things that you have to be able to do is mechanisms like this, where you're moving electrons, forming bonds. How do we show the electrons moving? So this actually is going to set you up in a really good position if you are doing chemistry in college and understanding this mechanism. Now, if you're the type of person that just cannot get your head around the movement of the arrows, that's fine. At Leave Insert level, if you can write the equations as we're going and then describe in words what the arrows are showing you, you're absolutely fine. So in my notes on page 346 and 347, if you include the boxes underneath the equations instead of the arrows, that's absolutely fine. You can get away with that. But it does help you, particularly when it comes to the addition mechanism, if you can understand what I'm doing here with the movement of the arrows. So I would recommend to give yourself an hour, sit down with a piece of paper and keep drawing them out. After an hour, you'll be flying, absolutely flying, because they're all exactly the same and they're going to give you the same answer every single time, and it's the same mechanism that's happening. Now, the next thing we're going to look at is the evidence for free radical substitution. This always comes up in relation to the mechanism. So you are always asked this. This isn't as if like you could suddenly get away without this. You can't. You need this. For this box, it's done out in your notes with the piece of evidence and what is that the evidence for? So you do actually need to know both boxes. Now, I would recommend that you learn 3 of these, but I want one in particular, and I'm going to put a star beside it and I'll talk about it in detail in a minute. I'm going to put a star beside the second last one. That one is super, super, super important because that comes up pretty much every year to every 2 years on the paper in some capacity. So we need that one. Now, let's go through the rest of them. So up the top. The reaction needs UV light in order for the reaction to begin. So that fact there, that it needs UV light, this reaction is not going to happen without UV light because the UV light is needed to cause the halogen bond to break and form the halogen free radicals. The free radicals don't form without UV light. For the next one, for every photon of UV light absorbed by the compounds, you will form thousands of chloromethane molecules. So even if you only blast 1 photon of UV light at the sample container, you will end up forming tens of thousands of chloromethane molecules, and that's because of the chain reaction step, which is step 3, propagation. Next, small amounts of ethane is formed, and this is formed by 2 methyl free radicals combining. And 2 methyl free radicals, well, the only way that you can form ethane here is with 2 methyl free radicals combining. No matter what way you smash methane into methane, you are never in a million years going to form ethane. You can't. The only way that you can form ethane is if you happen to have 2 free radicals combining. Next, now make sure you learn this one. Adding a source of free radicals such as tetramethyl lead or tetraethyl lead speeds up the rate of the reaction. Now, why? Because when you add one of those compounds, it provides a source of the hydrocarbon free radicals. So it's basically bypassing the first part of the reaction and it's giving you those hydrocarbon free radicals that can then contribute to the reaction. So if I go back a step, if I wanted to speed up this particular reaction here, which was the mechanism for the formation of fluoroethane. Now, this reaction, if I wanted to speed up, I need to give it more of these, the ethyl free radicals. So to speed this up, I would use tetraethyl lead. And what that will do is it will provide a source of ethyl free radicals. And then it will basically add in more of those ethyl free radicals, which can then go on to the next propagation step and away it goes. So it's basically bypassing the first 2 steps in that mechanism. So it helps to speed up the reaction. If we go to the previous reaction that we saw, which was this one here, doesn't want to move for me. Okay, so this one here. Now, for this mechanism, if I wanted to speed up this one, you have a methyl free radical here in step 2. So you would add tetramethyl lead, because that will give you a source of methyl free radicals, which will then go on to react with chlorine molecules, etc., and speed up the rate of the reaction. Now, if you're asked in the exam, what would you add to speed up the reaction? You need to look at the hydrocarbon from step 2 of the mechanism and then put that hydrocarbon lead into your exam paper. Next, if you were to add an inhibitor is something that can slow down the rate of the reaction. Now here, if you're going for this one, you need to be able to name an inhibitor, which would be oxygen. And what does it do? It slows down the rate. Why? Because the oxygen combines with free radicals and then it's basically mopping up the thing involved in the propagation step. So it's slowing down the propagation step of the reaction and you don't have as many free radicals for the propagation step. Now, for those ones, I recommend that you learn 3 of them. Definitely learn about the tetraethyl and tetramethyl lead and then pick any other 2. It's completely up to you which ones you pick. It doesn't matter. Now, we're going to have a look at an exam question. So we're going to look at 2019 higher level, question 10. Now, for this particular exam question, I've chosen this because there is a substitution reaction here, but it wasn't as bad as everybody thought it was, and it was really, really nice. The one from 2024 was actually more difficult than this one. So let's have a look at it. Okay, now there is my exam question from 2019. I'm just going to zoom in a tiny bit just to make it easier to see on the screen. So question 10A. So it is a 25-mark question. The mechanism for the substitution reaction between methane and chlorine in ultraviolet light involves free radicals. Number 1, explain the underlined term. So it's asking you, what is a free radical? Oops. So here, for part number 1, a free radical is an atom or group of atoms with an unpaired electron. Okay, so atom or group of atoms with an unpaired electron. Now, for that one, that in the exam, I have the mark scheme in front of me. I didn't want to keep switching the screen in front of you because it just looks a little bit messy. Now, for this one, this is worth 6 marks because this question was marked really awkwardly. It was marked as 6 plus 6 plus 3 plus 3 plus 3 plus 3 plus 1. And all of these marks add together to get me 25. So the first question that you get marks in your question paper will get you your first 6 marks. That's the first 6 in the list. Now, what we're looking for here was atom, and we're looking for with an unpaired electron, or has an unpaired electron. We needed all of that for the 6 marks. Now, number 2, or part 2. How are chlorine free radicals formed at the initiation stage of the reaction? Now here, I would actually give the mechanism part for this. So we have our chlorine molecule. You shine UV light on it. The bond breaks. One electron goes to one chlorine, the other electron goes to the other chlorine, and you form 2 chlorine free radicals. Don't forget to show the dot for the free radical. And we call this homolytic fission. Now, there's various different answers that can get you marks here. So if you didn't write it like I did, that's absolutely fine. You might still get your marks. Now, my second markable point in this is worth 6 marks. So I'm going to get 6 marks for that. Now, other acceptable answers here, I'm going to write them in yellow. If you did it as Cl2 in the presence of UV light and you just showed 2 Cl free radicals, that's fine. That's all you needed to show. If you wrote the word homolytic fission, that was also fine on its own for 6 marks. If you said the chlorine molecule is broken to give 2 chlorine free radicals, if you wrote it in words, that's also fine for 6 marks. So for your 6 marks there, you didn't actually need to show the arrows, but it's good practice to include them on your answer. For number 3. What name is given to the stage of the mechanism where the chain reaction is occurring? So it's called propagation. Now this is my third markable point, so I'm going to get 3 marks for this. In 2019, if somebody dropped marks for part 1 or part 2, whatever the first question on their answer is that they got right, that will get 6 marks. Whatever the second question on their entire answer is, they will get 6 marks. So say for example, a student got question 1 wrong, but they got 2 and 3 correct. They're still sitting on 12 marks out of 15 because they still get the 6 plus 6. It's not part 1 is worth 6, part 2 is worth 6. It's the first correct answer is worth 6. And the second correct answer is worth 6. And the third correct answer, whatever it is worth 3. My next one. Part 4. Oh, apologies, there's more to part 3. I missed that. Of course I did. Write balanced equations using dots to label the free radicals for the 2 reactions that repeat in the chain reaction to give chloromethane and hydrogen chloride. So this is asking me to write the 2 propagation steps. So the first one is where you take a chlorine free radical from step 1, and that reacts with a methane molecule. Now, when those two react, you're going to form hydrogen chloride plus a methyl free radical. Then your methyl free radical reacts with chlorine, the molecule, to form chloromethane, and you regenerate your chlorine free radical like that. Now, some people get a little bit sniffy here about how I showed the methyl free radical. The unpaired electron goes with the carbon, so if you draw it like that, with the unpaired electron on the carbon, that's absolutely fine. Or if you draw it as CH3 dot like that, that's also fine. We're not going to nitpick on that. But the unpaired electron is technically on the carbon. So there we go. Now, these are two separate answers. So my first one is my next correct markable point. So I'll get 3 marks for that. And I get 3 marks for the second one. Now, it's important here that you make sure that you show the dots for the free radicals. If they're missing, you're going to lose your marks. Next, number 4. Identify a hydrocarbon formed in this process. Alarm bells should be ringing. This is the longer chain hydrocarbon. Now, to figure this out, step 2 propagation is this one here. You have CH3. So to figure this out, you take CH3, your methyl free radical, and you times it by 2. That will be C2H6. So my longer chain hydrocarbon will be ethane. Now, it just said identify, so you can write ethane or you can write the formula C2H6. It doesn't matter. And for that, that's my next correct answer, which I get 3 marks for. Then the very last one. Explain why only a trace amount of this product is formed. Now, this caught everyone in 2019. Because in order for you to form ethane, 2 methyl free radicals have to combine. So 2 methyl free radicals must combine or collide. But your chlorine in the container is in a much higher concentration. So your methyl free radical are much more likely to combine with chlorine. There we go. Now, the reason why that was only worth 1 mark in 2019 is most students actually hadn't a clue what the examiner was looking for there. Now, acceptable answers are most methyl free radicals combine or react with chlorine, or collisions between methyl radicals is unlikely. Why? Because there's not that many of them. Collisions between methyl radicals is less likely than other collisions, or the probability of collisions between methyl radicals is small. Those last 3 answers are all the same. You can say the concentration of methyl radicals is small, the collisions of methyl radicals with chlorine is more likely, or the chlorine concentration is greater than the methyl radical concentration, or there's more chlorine present than your methyl radicals. So, by saying chlorine is in a much higher concentration than the methyl free radicals, I have actually got that last markable point because it's an equivalent answer. Now, that one, it was marked quite leniently, so as long as you're getting across that you have more chlorine free radical or more chlorine than your methyl free radicals, you're absolutely fine. Your examiner is going to give you the marks there. So that is what a typical substitution reaction. It asked for the steps in the propagation, it asked for the longer chain hydrocarbon, it asked how did the initiation happen, and it asked you for a definition. So that's the general format. What didn't come up here was evidence. It didn't ask you how would you speed up the rate of the reaction or why that particular substance speeds up the rate of the reaction. If I was asked that here, because we're forming chloromethane, we would use tetramethyl lead because it provides a source of methyl free radicals, but it wasn't asked in this particular case. Right, that is it for part 1 of the substitution reactions. So in the next video, we're going to move on and look at the second type of substitution reactions, which is esterification. But good practice before you move on would be to do the exam question from 2024. They're found in your exam question booklet, so make sure you download the PDF and have a go now.